Okay, so today we're just going to keep working with multiplying polynomials, but I want everyone to circle this right here. We're going to be working with special products of binomials. So what that means,
What makes them special?
we're going to get to that. So when we're working with a binomial, or special products of binomials, we're working with a binomial times itself. So this one right there, a plus b squared, that really means a plus b times a plus b, right?
Yep.
It's the same thing. So, you guys know how to FOIL, right? We've been doing it for a few days. Just right under here, let's quickly FOIL that. A plus b squared.
This is what confuses me. Do you have an eraser I can use? An eraser for myself. Put my phone. Now what?
Alright, so we FOIL it out. A times a equals a squared. A times b equals what?
AB.
AB. B times a equals?
AB.
AB, that's what Algebra Ed Kit says it would be. Then, last one, b times b is? Right, so we FOIL it out, so after we do that, we usually add all of our terms together, right? So are there any like terms in here?
Yes.
What are they?
AB and AB.
So we have one AB and another AB, so how many do we have? We have two ABs, so we'd have a squared plus 2ab plus b squared. So what we're doing today, these special products of binomials, we're gonna kind of have a shortcut for doing work. So a is our first term in our binomial, b is our first term. So no matter what is in, or no matter what binomial we have, whatever is our first term and whatever is our second term, it's going to come out to this. Oh, what word did you use? Model, yep. It's going to look like this model right there. A squared plus 2ab plus b squared. So,
Let's make sure we clarify that that only happens when you're taking a binomial times itself that has addition between the two terms.
so like right over here, we have a binomial x plus 4 being squared, so it's multiplied by itself.
Okay, I see.
So they identify a as our x, a is our first term, so x is our first term there. B is our second term, so they put 4 there. Then they just, well, let's write our model that we have. So we have a squared plus 2ab plus b squared. This is the model for a binomial times itself with addition inside. So this is our model. Then they just substitute in the values for a and b that they found. So all of a gets squared plus 2x times 4, so 2ab. Can't see it?
No, oh, it's just me.
Oh, well, I can zoom in. There you
you go.
go. There we go. Alright, so this is our model. They substitute everything in. So we're going to have two things always happen. First thing, our first term in our final answer is just going to be our first term squared. X squared becomes x squared. The last part, our constant number, our last term squared, so 4 squared equals 16. Then whatever happens is in the middle That's our O and I step in FOIL, right? So just like over here, even though they were flipped around, we still ended up with two of the same thing, right? So that's where that 2 times our first term times our second term. Alright. So now we have binomials that look like this. So it's a minus b squared. So let's quickly FOIL that one.
Are both those b's negative? Yeah.
Yep, these are negative b's. Alright, so we FOIL it out. Our f step, a times a is a squared. Negative ab, b squared. Do we have any like terms? What are they?
Negative
So we have one negative AB and another negative AB, so how many negative ABs do we have? So it would be negative 2 AB. Yeah, that's right. Oops. There we go. So just over here, they have another example, 4x minus 3 squared. They say our a is 4x and our b is 3. Where do they get that 3? If that's negative 3.
Well,
Jocelyn? You ever hand? No. Okay. Okay. Right, so this is just the model for it, right? The basic a minus b, that binomial squared. Usually we change any subtraction to add the opposite. When we're doing these special products of binomials, we actually get to leave that in there. So all we're worried about is that 3. So we're going to leave that subtraction sign and just worry about what number is over there. So that's where they get the b equals 3 thing. So just like up here, a is 4x, b is 3. They square our first term. Then they have 2 times our first term times our second term. So that's where the 2 4x times 3 comes from. And then the last thing is we square our last term. So this is our model, a squared minus 2ab plus b squared. So these are the answers we got when we FOILed it out, right? What kind of polynomials are those? No, Becca said it. They're trinomials. Yeah, so right there, we have perfect square trinomials. So every time that we have a binomial times itself, we are going to get an answer that is a perfect square trinomial. So this one we had a plus b squared, we got a trinomial as an answer. We had a minus b squared, our answer is a trinomial. So, for these first 3, it says to state whether each product will result in a perfect square trinomial.
Yeah.
So for number 1, x plus 5 times x plus 5, would that be? Because we could rewrite this as just x plus 5 to the second power, right? Like that?
Yeah.
Yeah, so if we can do that with two binomials, then we can say yes, the product that these two, when they're multiplied together, will give us a perfect square trinomial. So, number 2, yes or no? Why? Yeah, because there's different signs. We can't write it as just one binomial, right? So we would say no. How about number 3?
Yeah.
Why?
Because if you write it as 5x minus 6
Right, so we have the same first term, we have the same second term, and we have the same subtraction sign in both of them, so we can rewrite it as one binomial squared. So we can say that yes, this would give us a perfect square trinomial. Now, just moving on, so number 4, x plus 7 squared. Do you guys think that's going to give us the perfect square trinomial?
Yes.
Yeah, because it's a binomial times itself. So what is our a in that binomial? What is our first term? X. What's our b, our second term? 7. So then we just follow our steps. So we put our first term in parentheses and square it. And what is x to the second power? X squared. Second one, we have 2 times our a and our b. So we have 2 times x times 7.
2x, or I mean 14x.
And the last one, we square our b term. So 7 squared. What's that?
49.
49.
Do we have problems like this on the worksheet?
Mm-hmm.
So do we have to go through and write all that work out? Or will the answer be okay?
Yeah, as we get down here, yeah. So you won't have to write the square a, 2ab, things like that.
Well,
Just
I mean, like,
this
the
part.
parentheses and all that. Do we have to do that? Or can we just write x squared or 14x and 49?
You have to show the multiplication, is that what you're asking?
Yeah, basically.
Yes.
Okay.
So we have all our terms left. So what kind of model would this one look like?
perfect square trinomial.
Mm-hmm. So we just put them all together. So x squared plus 14x plus 49. And there you go. All right, number 5. What's our a? Or a is what? X, our first term. What's b? Are you sure?
Yes.
There's only
It's
Positive one.
Oh,
It's just positive 1. Yep, when we have a binomial with a subtraction, we're going to leave that subtraction in there, and we're just going to take the value of our second term. So that would just be 1.
These are all probably.
Hmm?
So these are all
Yep. So then, just follow our steps. We square our a value. X in parentheses squared becomes x squared. 2ab. So just substitute in our b and a. Not b. B is number 1. Equals 2x. Then square of b. So what model does this one look like? At the top of our notes, we have 2 of them. Does it look like the bottom one, or the top one, or the bottom one? So this one right there, at x minus 1 squared, bottom, right? So it's gonna look like a squared minus 2ab plus b squared, right? So we have our first term, that goes first. Then we have that minus our 2x, and then we just have our, not b squared. Just tack that on. All right, number 6. You guys tell me what to do.
No,
A is 2x,
B is 10.
B is 10.
Okay,
Square 2x.
like that?
Yeah.
Yeah.
No.
But
Yeah,
that
parentheses.
That's right, we have to take our whole a term and square it, so 2x times 2x.
It's 2x squared.
4x.
4x.
There you go.
Third, yeah.
Okay,
2 parentheses 2x. Parentheses 10. 40x. 4x. 40. Or 20x.
And then you square 10. That gives you 100. Yeah, you write your equation.
then we write our equation. What model does this look like, the top one or the bottom one? So are we gonna have 2 addition signs or a subtraction and an addition?
2 addition.
2 addition, that's right. So just add everything together, 40x. All right, so number 7, we have x minus 8 squared. Is this going to give us a perfect square trinomial?
Yes.
Yeah, because it's a binomial times a by itself, right? So, what's a?
X.
A is x. What's b? 8. Then what model is it going to look like?
Bottom.
The bottom one, so let's write out what it actually is. So it's a squared minus 2ab plus b squared. So this will help on your homework to keep track of what it should end up looking like.
So we have to write that. And then we write the example there.
Not quite. Once we get to other problems, that'll be the work that you have to show.
This is the work he has to show.
Oh.
Right here. A is what, B is what, which model are you gonna use, and then we'll show substituting
That's
into
what I
it.
have to show up as a model.
Showing you the work you've gotta show on your homework, right now.
So, it's just substituting our a and b. X squared minus 2 times x times 8 plus 8 squared. So we're substituting all of our a's and b's in. So x squared is just x squared minus 2 times x times 8 is 16x, and then 8 squared is 64. All right, we're gonna skip number 8 for now, so let's jump to number 9. So A is 7x, B is, what model is it gonna look like? So that's a squared minus 2ab plus b squared. And you just substitute in your a and b values. Alright, so we have our first term squared, 7x squared, what's that equal? 49x squared, because 7x times 7x, 49x squared. Second part, what's 2 times 5? 2 times 5?
10.
What's 10 times 7x? 70x. And then 5 squared is 25? Alright, you guys do number 8 by yourselves now. Alright, so x squared just becomes x squared, right? Then we have 2 times x times 2 is 4x, and then 2 squared is 4. Everyone get that answer? Awesome. So all of our answers here were what kind of polynomials? Perfect square trinomials, because we took a binomial times itself, and we always get perfect square trinomials from it. Okay, now moving on to the back side, we have a plus b times a minus b.
Cancel each other out.
Is this going to give us a perfect square trinomial?
No.
No, why not?
Because.
One's gonna be a negative AB, and then one's gonna be a positive AB, and they're just gonna cancel each other out.
Right, so here they foiled it out for us, so we don't have to do that, but a times a is a squared. A times negative b is what?
Negative AB.
Negative ab. B times a is
AB.
ab. And then b times negative b is
Negative B squared.
negative b squared. Are there like terms in there?
Yeah.
Mhm. What's going to happen to them?
Cancel.
They're going to cancel out. Because a negative ab plus a ab
Shut it down.
becomes 0. So, what just happened here, or what would be left is what I should say.
A squared minus B squared.
a squared minus b squared. And this kind of special product is called a difference of squares. The reason it's called that is because it's a subtraction problem, so there will be a difference after we're done. And it's called difference of squares because first term is a square, second term is a square, difference of squares. So they have two examples there. They have x plus 4 times x minus 4. So if all that's going to be left is our a term and our b term, and we identify our a and b, a is x, b is 4, what do you think is going to be left for an answer? Yeah, our a term squared minus our b term squared, so x squared minus 4 squared. X to the second is just x squared, 4 squared is 16. So our answer for that one is x squared minus 16. And over here, 7 plus 8x times 7 minus 8x. What's a? What's b? So is this going to give us a difference of squares? So it's the same first term, it's the same second term, and all that's different is one's addition, one's subtraction. So, we square our first term, 7 squared is 49, square our second term, 8x, 8x times 8x becomes what? 64x squared. So 10 through 12, we get to try to state whether the products will form a difference of squares, what we just did here, or if they'll form a perfect square trinomial.
The last two form a perfect square trinomial.
So number 10, is it going to be difference of squares or perfect square trinomial?
Difference.
Why?
Because one's negative, one's positive.
It's the same two terms, same first term, same second term. They're just addition and subtraction, so this is a difference of squares. How about 11? So if it's going to be a perfect square trinomial, we should be able to rename it as something, right?
Yeah.
And what would that be?
Y + 6.
Y plus 6 squared. Since we can do that, we know that it will give us a perfect square trinomial. And while I'm writing this one, you guys tell me what number 12 is going to be.
Perfect.
Because we can rewrite this as z minus 3 squared. You guys are good at this.
I know.
Alright, so just gonna do what we did on the front page, but with difference of squares. So a plus 7 times a minus 7. What's our a term?
A.
It's actually a this time. It won't always be, but a is a,
7.
b is 7. So
A squared.
square a, so we have a squared equals a squared.
7 squared is 49.
7 squared equals 49. So what we should be left with is what? I heard plus and minus. Who's right? Minus. Because it's a difference of squares, so there should be a subtraction sign in there, right? Alright, 14. A is what? 2. B is what? 3m. So the term has our variable won't always be in front, but that shouldn't matter, right? So we square A, 2 squared equals what?
4.
4. Yes, I'm so enthused. And we square our second one, 3m times 3m is
9m squared.
9m squared.
9m squared. And how should we write our answer?
4 minus 9m squared.
But doesn't the
Hmm?
have to be first?
Hmm?
Yeah. Doesn't the variable have to be first?
It doesn't have to be, but it would, when it is in front, that just means it's in standard form. So is this in standard form? No, because the term with the greatest degree isn't in front. But yeah, it's fine if we write it like this. Alrighty then. Number 15, I'm gonna go through with you so you guys know what you have to show on your work. A is what?
X.
A is X, B is what?
8.
B is 8. Then our model for difference of squares is what again?
X.
X squared minus 16.
Squared minus B.
It's just A squared minus B squared. This is just the general look of it. So then we square our A value, X squared minus 8 squared.
X squared minus 64.
This is a lot easier than boiling it out every time, right?
C.
Mm-hmm. All right, you guys do 16 by yourselves. So when we square our A term, our A is 10 minus our B term, which is 2x squared. 10 times 10 is 100. 2x times 2x is
4x squared.
4x squared.
Yeah.
Why am I so enthused? Because this is the easiest way we can multiply binomials.
That's why I'm liking it,
Why didn't you
but
learn this way first?
Because
he likes to make crap on you.
these are just shortcuts for when we're multiplying binomials together. So we can only do this if, so, when we have a binomial times itself, what is our answer going to be?
That's
Perfect
squared.
square
Perfect square trinomial. So if it's a plus b or a minus b, if it's being multiplied by itself, we should always get a trinomial answer, right?
Yeah.
Then, on these ones, as long as we have the same first term and the same second term, and the only difference is in addition and subtraction, what is our answer going to be? Difference of squared, that's right.